Dear student, how dispersed phase is formed and positive or negative charge ions are absorbed on the dispersed phase and it becomes positively or negatively charged dispersed particle. So let's go with the illustration and that you understood how positively or negatively charged sol is formed. As for example, that the dispersed phase will take silver iodide, which is formed by reaction with potassium iodide, aqueous solution, very dilute aqueous solution, react with silver nitrate, very aqueous solution, then it forms silver iodide precipitates with the KNO3 aqueous solution. So here you can see the both reactions are given, in which in first case, example number 1, if negatively charged dispersed phase particle obtain of silver iodide, then what we will do, that we will take a very dilute solution of Ki in this beaker. You can see here that in beaker A, we will take a very dilute aqueous solution of Ki and a very dilute solution of AgNO3 silver nitrate we have to add in small proportion. Here you find that Ki is in excess proportion, whereas AgNO3 added in a few drops or some proportion. Then this reaction takes place in this beaker A, that AgNO3 reacts with Ki and a precipitates. We will express with the arrow or solid sign that a precipitates of AgI dispersed phase is produced, that is called dispersed phase as a precipitate, and along with KNO3 is in soluble form, aqueous form. Now what happened in this dispersed phase particle are heterogeneously distributed in dilute solution or mixture of Ki and KNO3, that excess Ki is dissociated in water or ionized in water in K plus and I minus. Here the I minus negatively charged particle attracted towards surface of AgI. AgI is a precipitate which is formed in this reaction beaker A. Now you find that I minus ions are attracted and adsorbed on the surface of AgI dispersed phase particle. Adsorption takes place of I minus ion. Separated you can find out like this, that I minus ion, I minus ion, I minus ion. These I minus ions are adsorbed on the surface of the dispersed phase particle precipitates that you consider as a AgI silver iodide, and a make fixed layer, and then you consider that the AgI you can consider or write like this, that the AgI slash I minus dispersed phase negatively charged sol formed in dispersion medium as water. That you understood very well. How this, with the one molecule you can find that how this type of negatively charged ion is formed in this beaker, and that becomes a colloidal sol or lyophobic sol of silver iodide as negatively charged sol. Similarly, you will find that in solution of AgNO3 that we take in beaker B, and then we pour. In second example, we got positively charged dispersed phase or colloidal sol with the same PPTs of AgI. You take that a very dilute solution of AgNO3 सिल्वर नाइट्रेट का dilute solution बीकर B में लेंगे and drop by drop very small amount of Ki solution we will add in this beaker. Then reaction takes place like this and a silver iodide precipitates is formed. That silver iodide precipitates in solid form takes place along with aqueous solution of KNO3. Here we are taking AgNO3 is in excess amount. अगर AgNO3 एज ए डिस्पर्जन मीडियम हमने डिस्पर्जन मीडियम में वाटर में एक्सेस अमाउंट में लिया है एक्वियस सॉल्यूशन, तो उसका डिसोसिएशन और आयोनाइजेशन होगा और Ag plus particles, positively charged particles are attracted towards this dispersed phase. You can consider that is AgI silver iodide के ऊपर Ag plus के particle. You can consider here that the Ag plus positively charged particle Ag plus are attracted. Ag plus positively charged ion attracted on this precipitate and it adsorbed on the surface Ag plus. That you find that Ag plus particles are adsorbed on the surface of AgI, that is the dispersed phase, and make a fixed layer that you find from here that plus positively charged. The similar thing is happened and then you will obtain that AgI slash Ag plus positively charged lyophobic salt. So how positively charged lyophobic salt with the silver iodide precipitates? When your excess amount of AgNO3 is taken and mixed with the very dilute solution of Ki, then positively charged AgI silver iodide colloidal salt is obtained, but you will take excess amount of potassium iodide and the less amount of very dilute solution of silver nitrate is added, then you will obtain that silver iodide negatively charged lyophobic type of salt. So that you understood that how the positively charged as well as negatively charged salt of a silver iodide is formed according to the proportion of reactant as well as reagent. Now the second thing you can understood with the same thing, that not only the one layer is formed on the surface which is called the fixed layer, but along with the second layer, that here you will find if Ag plus, suppose we will go with this earlier example. Suppose in case of this, that you will find that AgI silver iodide as a dispersed phase that is adsorb negative ion minus I minus and make a fixed layer. Negatively charged ion का एक fixed layer form करेंगे, that you consider as fixed layer. अब क्या होगा कि ये सॉल्यूशन के अंदर कुछ K plus ion भी प्रेजेंट है, K plus, that K plus ion is dissociated by excess amount of Ki. तो वो जो K plus ion है, this is also attracted towards this negative charge. Then K plus, you will consider that K plus, here you find that earlier is I minus. I will write one example, I minus, iodine minus, and it is attracted towards K plus ion, and it makes a movable, mobile और diffused layer means ये जो upper side का layer है वो continuously move होता है, and that's why it is called movable और mobile layer और diffused layer. अब ये diffused layer के बाहर फिर से I minus का layer आएगा. You can consider like this way that I minus, I minus, I minus, I minus, I minus, I minus, that is also that mobile layer. तो इस टाइप के लेयर फॉर्म होंगे पूरे सॉल्यूशन में, एंड दैट्स व्हाई व्हाट हैपेंड दैट टू dispersed phase particle cannot comes to nearer due to the opposite charge, like charge are repelled to each other, and coagulation or aggregation does not take place, and it does not becomes settled down. Second thing you can understood that this mobile layer, this combination of these two layers, that fixed layer and mobile layer, is called a Coulombic layer or electrical layer, and potential difference you will find between this negative and positive charge, positive and negative charge, that is called zeta potential. Zeta potential. Zeta potential or Coulombic potential or electrical charge potential. So, due to this potential difference, some electrical potential is also created in this type of colloidal salt, which make it stable. So, how charge is deposited on the surface of silver iodide, and what is the fixed layer, what is the mobile layer, how zeta potential or electrical potential is formed, that you understood very well with this figure. You can see all the things. Dear student, let's take a second example. दूसरे एग्जाम्पल के साथ यही चीज फिर से डिस्कस करते हैं. How positively charged and how negatively charged dispersed phased ion obtained in dispersion medium, and that positively charged colloidal salt or negatively charged colloidal salt are obtained. Example number A. Positively charged salt is obtained when a ferric chloride ion, ferric chloride 2FeCl3, ferric chloride is added in warm water. बहुत ज्यादा बॉइल भी नहीं होना चाहिए, बहुत ज्यादा कूल भी नहीं होना चाहिए. वार्म वाटर में ऐड करेंगे, then it chemically react together and convert into ferric oxide Fe2O3 plus 6HCl, that is in aqueous form, and that is in a solid form. This solid Fe2O3 reacts with water molecules XH2O, and Fe2O3 XH2O dispersed phase particle is formed. You can see here in beaker A. In beaker A, we will take that H2O with the warm और थोड़ा सा हॉट वाटर लेंगे और उसमें FeCl3 पाउडर या एक्वियस फॉर्म में ऐड करेंगे, तो केमिकली रिएक्ट करेगा एक दूसरे के साथ. That FeCl3 react with water molecule and produce this type of Fe2O3 ferric oxide. This ferric oxide वाटर के साथ रिएक्ट करके आपको एक dispersed phase particle like this Fe2O3 dot XH2O एक dispersed phase particle produce करेगा, and it is heterogeneously distributed in warm water. That you understood, and that you can see in this figure. Now what happened, that excess amount of H2O का excess amount है, और excess amount of H2O के लिए जो FeCl3 थोड़ा सा हमने ऐड किया है ट्रू इलेक्ट्रोलाइट, it can dissociate in this H2O in Fe3 plus and Cl minus. This Fe3 plus ion is attracted towards this particle and it is adsorb. Fe3 plus, Fe3 plus, Fe3 plus, Fe3 plus adsorb on the surface of this Fe2O3X H2O dispersed phase particle. Fe3 plus, Fe3 plus, Fe3 plus, Fe3 plus, and make it a fixed layer. Fixed layer. It cannot movable because that each Fe3 plus is directly adsorbed on the surface of Fe2O3X H2O, and अगर वो adsorb हो रहा है, chemically adsorb हो रहा है, then it makes a fixed layer, not a movable layer. And that a positively charged dispersed phase is heterogeneously distributed in this dispersion medium water, and that's why positively charged salt of Fe2O3.X H2O in water is obtained. That you understood very well. Similarly, here you find that the FeCl3 aqueous solution is added in excess of NaOH, alkaline, basic medium, and small warm heat it, then it forms Fe2O3, that is in solid form. Precipitation takes place, solid form, with the 6 NaCl aqueous. Now, this Fe2O3 ferric oxide react with water which is present as aqueous medium and form Fe2O3.X H2O dispersion phase, like this. You can find in this that Fe2O3.X H2O, that is the dispersed phase precipitate particles are formed, from which that negative ion OH minus is attracted. Negative ion OH minus is attracted. OH minus, 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 and attracted towards this precipitate and make a fixed layer. Make a fixed layer on the surface, and due to that adsorption of OH minus, the dispersed phase particle acquire negative charge, and that's why you consider that is the negatively charged colloidal salt of a ferric hydroxide hydrated salt. Now that is the fixed layer. You will find that fixed layer attracts the positively charged ion, that is Na+. So you will find that it is attract Na+, 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 Na+. मैं सिर्फ यहाँ पर ड्रॉ कर रहा हूँ. You can find this. It is not a fixed layer. It is the movable or mobile layer और diffuse layer, and ये layer continuously move करेगा, and again it is attract this OH minus. तो ये दोनों लेयर के बीच में एक पोटेंशियल डिफरेंस प्रोड्यूस होगा. दैट पोटेंशियल डिफरेंस इज कॉल्ड इलेक्ट्रिकल पोटेंशियल डिफरेंस और जीटा पोटेंशियल. और ये जीटा पोटेंशियल की वजह से ये दो कोलोइडल डिस्पर्जन फेज जो है, डिस्पर्स फेज है, वो कोएगुलेट नहीं होते, एग्रीगेट नहीं होते, और इसकी वजह से वो सेटल डाउन नहीं होते. एंड दैट इज stability of lyophobic salt is dependent on the charge of particle. लेकिन अगर excess amount में मैंने FeCl3 ऐड कर लिया तो क्या होगा कि Fe3 plus is attracted towards OH minus, OH minus, OH minus, और Fe3 plus का लेयर फॉर्म होगा और पूरा FeOH thrice में कन्वर्ट हो जाएगा and it becomes settle down. So the excess impurity of FeCl3 is responsible for the coagulation of salt, और ये जो नेगेटिवली चार्ज डिस्पर्स फेज पार्टिकल है वो न्यूट्रलाइज हो जाएगा with the Fe3 plus ion, which you find from here, that excess Fe3 plus is adsorbed on the surface of OH minus and FeOH thrice is formed, and it's a bigger particle more than 1000 nanometer size, and it becomes settled down and coagulation or precipitation of FeOH thrice takes place. So you can understood what is the zeta potential or electrical potential difference is found, and these two layers are combinedly known as Helmholtz dipolar layer or dipolar layer. That you understood very well. With these two illustrations, you can understood very well that how the colloidal charge acquire positive or negative charge and become stable in salt. That thing we will find in our NCERT book. We will read and try to understand very well. If you like this video and understood very well, then please like it and subscribe. Also share with your friends. Good day.